Okay, so this is a video to gear car assembly number 2. This is going to be the gear car assembly number 3, part 3. Basically where I left off last time is we went through and assembled most of the base, and then that second part we went ahead and added in our gear train. Okay, and I walked you through how to set this up by adding gear mates and working basically from the wheel back. So when we were done, we were able to spin this and see everything work together. Okay, that's where we left off last time, and that was a long video, so I'm gonna make this one a little bit shorter and try to break these up in smaller pieces. Specifically what I'm gonna do is I want to finish off this gear train and then add an animation and then show you how to save that animation so you can upload it to Schoology. Before I can finish this, a couple things I want to add in here. Okay, so first and foremost, I talked about last time the spacing that was going on with these gears. To me, they're too far away from the original gear block. So what I want to do is I want to add in some more material here in order for my gears to be closer and have a sturdier connection so they don't vibrate themselves in the point they lock together. Okay, because you got to imagine a screw here going in here with a bunch of washers. This thing's going to vibrate up and down. That's not good because it's going to eventually get caught and bind up inside this gear and it could break itself. Okay, so I want to make that a little bit tighter. Now, a couple of you, I saw that when you turn yours in, you had already developed your block in order to have everything tighter. But the problem I saw with a lot of you that did that is you treated this block as one giant piece of wood. You got to remember, I want you to treat this as if you were actually going to build this for real with laser cuts and glue. So that means if I have, let's say, a block behind this gear and another block over here behind this gear, I should see 3 distinct pieces of wood. And a couple of you had to comment on that, and I'd like you to go back and fix that. Okay. In my case, I just wanted to bring in one piece of wood because the second one or third one, it just gets too thick and it starts to bump, and I was going to have to start adjusting these gears. Now, in truth, if I were to build this car and put it together, most likely I'd end up cutting a small piece of wood here for the third gear just to ensure this gear is nice and firm. Okay. For this purpose, though, I only did one more gear. So what I did is I went ahead and created a new gear block that looks like this. And basically what I did is I made this gear block 1 9/16 long. I know it's an odd number, but I was fine-tuning it. I'll be up front. I brought it in as a 1 3/4, realized it was going to hit the gear in front, and began to chop away at it until it was about the size I wanted with enough wood between the hole and the edge here so that if I put a screw in, it will not break. You don't want screw holes right next to an edge because it will split the wood. Okay, I made it 1.375, which was the original size of the first block. What I did from there is I came in and I mated that in. First thing I actually did is I brought that spacer. I was telling you guys about that adapter. And in our gear cars, if you were using this 13-tooth gear to actually build, the hole is too big for the motor. What they do provide for these 13-tooth gears is what's called a spacer or adapter reducer. I showed it with you in the last week. I also showed it again this week. If you would like to download and put that in there, that's up to you. You don't have to. I just like it because I want to be as realistic as possible. Okay, so I went ahead and put this in here. All this was a concentric and a coincident mate. Essentially what it does, it has a small hole that squeezes onto the motor shaft, and then it goes inside and squeezes firmly inside the hole, so these two basically lock together onto that shaft right there. Okay, so I started with doing that. I then came in and created that new gear block. I called it gear block number 2 and dropped that right in here. So I created it, brought it in, and then I edited this back block so that I could add in these 2 holes to make sure I have pilot holes for my screws. Okay, now when you're done, I want you to notice here, these are 2 very distinct pieces of wood. Like I said, in some of the ones I graded so far, this was treated as one block of wood. That can't happen. The laser cannot cut that way. Okay, what I would do with the laser is cut you this block and then cut you that block, and you would glue the 2 together. Okay, so I created that. Now, if I were actually building this car, okay, got all the parts cut, I glued on my wheels or my wheel holders, I put my axles through, I got my gear. What I would actually do is build this gear block by itself. Okay, what I mean by that is I take my 2 pieces of wood that would come off the laser cutter. I would then glue them so that this base back here, these two walls are exactly flush, that the bottom's perfectly flush. And then after they dried for about a half an hour, I would come in and take my gears. So I'd treat this as one individual piece by itself. I'd sit on the table and I would start grabbing my gears. Okay, I'd grab my 13/38s that have been super glued together, and I would begin to take a screw and begin screwing these into the block. Okay, so one of the things I share with you was some screws. Okay, and I specifically on mine used the long screw just because I wanted to make sure it bit into the wood so it was nice and firm. But I added 3 screws. Again, nothing more than a concentric and coincident mates. All right, now I'd have these all on here. In addition to that, I would add in some washers. Now, I added a bunch of washers, and I'm going to show you where they're all at, okay? I added quite a few. It'll make sense in a second, but one of the things when I build these is I always put a washer on the front so that basically with a little bit of graphite in there, this can spin freely around the head of this screw. Okay, it's the same on the back side. I also add washers. In this case, I added 2 for the space so that this gear does not touch this wood. I don't want to cause any friction whatsoever between my gear and wood. This is plastic. It's hot. I promise you. It will melt. And it will melt together and it'll turn into a big blobbing mess. Okay, I've had that happen. All right, it's the same with this one. I put a washer in the back. Again, I put a little graphite right there. I would screw this in. Not so tight. I would just screw it firm enough that this can spin really freely. And then I would add in this last gear, drop it in so that it meshes perfectly with my 13. Put my screw and washer. In this case, I used a big bunch of washers, 10 in total, to create this gap right here. Now, truthfully, it'd probably be wiser to actually add in another piece of wood, so I'd only have to add in maybe 1 or 2 washers. In this case, I've done this before. It works, and it actually works pretty well. So I added in 10 washers right there, okay? Again, I would tighten this by hand, make sure this whole entire block of 1, 2, 3, 4, 5 gears spin very freely. And then what I would do is I would put glue all on the bottom of this 2 pieces of wood down here, and then I carefully take my piece of wood and carefully get it to where it meshed perfectly with my back wheel gear here, and then I'd press down and let this glue dry for about 30 minutes. The last thing I would do then was put my gear on my motor, put my motor inside here, put a little bit of glue on the bottom of these, or you could screw them in, it's up to you. But then I would just slide my motor until it nicely meshes and then press down or screw in, and now my entire gear train would be done. Okay, if you did it correctly and actually built this, that is how easy this would become. Again, if you spent the time getting this gear block right, these gears should be perfectly meshed together, just enough play that they should be absolutely moving very smoothly. Okay, so that is where I got to and left off after I did the last film. Okay, I finished this piece up. My gears are all still working together. You can see if I rotate, I'll grab any one and start to twist. You can see everything is still meshing the way it was intended to mesh, and my wheels are still moving. Okay, so everything is good here. All right, I like what I see. My gears still look good. All the teeth are lined up. We are ready to add a simple animation to this. Okay, now for future site, I'm probably going to ask you for screen captures from multiple directions of your vehicle. One of the things I noticed when I get graded is some of you, I don't know where your switches were. I couldn't find them, or they weren't shown very clearly, or you forgot them. I don't know. Same with the kill switch. Like on mine, you can't see the kill switch. So I don't know if it's in there. So I would, for me, looking at a picture, I would downgrade you because I wouldn't know it's there. So as we start to develop these, I'm going to ask you for 1 or 2 pictures, usually 2, maybe 3 or 4 pictures. And what I mean by that is I may have you do a screen capture of this orientation. Then I may have you do one from this orientation. I may have you do one from this orientation. That way what I can do is see all the pieces and parts you're adding to your vehicle. So when you do your final gear car, as I begin to develop mine and start putting the body on there, I'm going to screen capture multiple views of my body. Okay, if you have something hidden on the bottom, you can do the same thing. You can use this block if you choose I can hit this bottom corner, and now I can look at things underneath the car. So as we get going through this, there's going to be times I'm going to ask you for 4 different views. Please upload them so I can see all elements of your car. All right. For this case, though, I'm going to go back into my isometric. Excuse me. And now what I want to do is I want to create what's called a motion study. It's a real simple animation. All we're going to do is tell the gears to spin. Okay. And if we've done all of our mates correctly, locked them in with our gear mates, got all the wheels locked in with their planes, and everything's locked together, if I animate the first gear, the entire gear train should work. Okay. Now, to get an animation set up, if you look at the bottom of your screen below your design tree, we're in the model tab. If you come on down to motion study, now I've already done a motion study once. I'm going to go to here. You're going to click on motion study 1. I created a new one, so I'm going to go to motion study 2. Right now it's a blank canvas. Okay. All this is basically like you're creating a film clip. You can do different types of animations. I could do a motor, I could do a spring, so I can see something bounce. I can see something with just contact simulation, such as a cam. I can do things with gravity. So if I have something that's going to come falling off a machine, you can actually see the effects of gravity in an animation. Okay, all those things are on there. And if that interests you, there are tutorials online. There's tutorials built into SolidWorks that will show you all these. I'm only asking for one for this entire model. Okay, the one I'm going to ask for is the motor. So I'm going to left click on this little blue icon and turn my motor on. All right, you got 2 choices of motors. You can do a rotary, spinning, or you can do a linear, okay, like an actuator, like a push rod. It pushes in, it pushes out, pushes in, pushes out. That is a linear motor, okay? Our case, we're doing rotation because our motor is going to rotate, all right? Now, the first thing I want to do is I want to pick something to spin. All right, now a lot of you probably, oh, I'll just turn and click on the motor. I'm going to actually make it real simple. I want this 13-tooth gear right here. I'm just going to pick the edge of it. I want this 13-tooth gear to spin. Okay, that's it. I just want it to spin. If that gear spins, because I know I've got my gear mates on, if this gear spins, I know my other gears are spinning. Okay, so I'm just going to hit that edge of my gear. All right, it automatically chooses it. All right, now speed, it's going to be constant. I will tell you right now, 100 is a little fast, 10 is a little slow. I use anywhere from between 20 and 50, depending on how fast you want to show this. I find that 25 works pretty well. So I'm going to do 25 RPMs, enter. Okay, right now my motor is going to be turning counterclockwise, which is fine. I don't have a problem with that. If for some reason, though, I find that my wheels are going backwards, all I'll do is come back and edit the motor, and I will change the direction right here. I will just flip it and say reprocess, and the animation will actually go the other direction. The beautiful thing with a DC motor is if we realize that you're connecting it to a battery that the wheels go the wrong way, all you'll do is take the 2 leads off and flip them, and it will go the right way. Okay, so I'm going to go ahead and leave it at this point right here. Okay, I'm going to hit my check mark, go to my isometric view here, and then you'll notice right away this little diamond suddenly jumps out to 4.5 seconds. And basically what it's saying is the motor's going to run for only 4.5. I don't want that short of an animation. I want an animation that I can watch for a while. So I would like anywhere between 20 and 30-second animations. I'm just going to drag this diamond with a left click. I'm going to drag it out here to 20 seconds and let go. You'll notice now the motor's going to run for 20 seconds. Now to make this work, I've got to process this animation. I've got to calculate it. If you look up here to your left, you're going to see like a little table with a cog. It says calculates the motion study. I'm going to left click, and what it's going to do, it's basically going to like process a movie clip. That's exactly what this is going to be creating in a moment as an AVI file. So I am going to go ahead and left click on that. It's going to start animating. Now don't worry, it's jumpy. It's basically digitally capturing each frame like it's capturing film. Okay, when it's done and I go to hit play, you will notice it's a lot smoother, and I'll be able to see that my actual wheels are working. The good news for mine is I see my wheels are going forward because here's the front of my car. That is a good sign. I don't have to change my motor. Okay, the animation now has been fully calculated out to 20 seconds. If yours is all the way up to 30, awesome. Now to make this work, I'm going to take and hit the play button, And now you can see my gears are spinning together, my wheels are going forward, everything looks really good. Okay, now again, if this isn't fast enough for you or it's too slow, you could go in and change your RPMs like to 50, maybe to 75. If you want to go with 100, you can go with 100. I'm not critiquing you on how fast your wheels are turning. Just remember, if you have a very high gear ratio, like close to 100 to 1, you want to kick the RPMs up a little bit, because what's going to happen here is this back wheel is barely visibly going to be moving. Okay, remember that. If you're sitting back here with a high gear ratio, now mine's just under 40 to 1, so I could do a 40 RPM so I can get one maybe loop of my wheel, but that's up to you. Again, if you want to change that, you can simply right click. You can go into edit feature. You can change your RPMs from 25 to something else and move from there, or you can flip your motor over and rerun it. Okay. When you're done with your animation, I'm going to stay with this one because I like it. I'm going to do a quick save so the animation saves with my assembly. Okay, I'm going to say a save all. Now, the last step here, again, if you want to watch this, I can hit play again. That looks good. See, everything's moving. I'm really excited. This looks awesome. Okay. I need you to take and copy this video and send it to me. Okay, I need you to upload it to Schoology. The way you're going to do that is when the video is done, you're going to see in this top bar right here where it says save video. Okay, save animation. It says right here, saves animation as an AVI or other type file. The cool thing is, if you got really good with these animations, you could actually save these and bring them into things like iMovie and actually create movie clips of your gear car doing cool stuff. Okay, and if you, again, you want to play with this, there are tutorials or some really cool videos on YouTube that really go into detail on how you make awesome animations. I'm only asking for you to save this one. Okay, so I'm going to go here and save this. It's car-based subassembly AVI. That's fine. I can, if you want to save it to something else, you can save it as an MP4. That's what probably I'd rather you do. I like the MP4 better, file quality, and it's smaller. So I'm going to go ahead and do an MP4 video file. I'm going to save it in my gear car folder because I want to keep it. Image aspect 1920 by 755. That's fine. Don't care. You want to go high def, you can go high def. I can do HD TV formatting 16 by 9. Make it look like this. You can play around with this. Okay, I really have no set things. All I ask is that you save a video of decent quality. Okay, as soon as you're done, you hit save. All right. So right now, the reason it's going slow, it's in the process of saving this file. Don't panic. It takes a second to save everything, because what it's doing is basically processing it like a video processor, and then it will save itself into your folder. Okay, and then I'm going to show you in a second where that is located. I'm going to show you it in my folder. I'm going to show you when you double click on it, it actually turns into a movie file so that you can show this to your parents if you'd like to. Share it with them or share it with your friends. And then that file is the one you're going to upload for me into Schoology. Okay, and this is due by the end of the week. I'm going to finish this process here. As soon as that's done, I'm going to show you where the video file is located. So almost there. Process looks good. Liking my car. Pretty stoked by this, to be honest with you. This is turning out pretty good. Okay, again, my gear ratio, as you saw in the calculations, is just under 39 to 1. Okay, it's taking a second here. You'll notice the reason it's pausing here is just kind of finalizing everything. At this point, it's been saved. The file's been processed. I'm just going to hit save one more time on my gear car and save all. And at this point, I'll show you where my movie is located. So I'm going to go into my folder here. I have everything right now on my desktop. Maybe you do too. Gear Car 2020. And what you're going to see here is a gear car based subassembly MP4. If you want to watch it, you can double click on it. In this case, you may have to open it with something else. Depending on hopefully you have a movie file over on your computer. I'm going to open mine with, I'll go with the HBC4. Here we go. And there is the video that you are going to send me. And this is what I'm going to watch and grade. Pretty cool, huh? A little bit smoother. Looks kind of cool. I probably could have picked the RPMs up a little bit, but I'm really happy with what I see. I know my gear car is structured right. My motor's doing good. My gears are meshing. My wheels are turning. Okay? And with that, that is all I have for you. Okay? This is what I want you to get settled up and done. Next video, I'm going to begin talking about how to start to create your drawings. Actually, yeah, your drawings for this gear car, but I'm also going to do in the subsequent videos how to start creating a body using sketch pictures. Okay, some of you are doing some awesome work. Keep it up. I'm excited for some of the things I've seen so far. Those of you that have made comments, go ahead and clean those up, and let's continue moving forward. If you have any questions, email. Take care.